Hello everyone. In this video, we are going to look at some multiple choice questions in PAT 2017. I will talk through the working process and how to approach each question. So, question number 7. An astronaut on the surface of the moon lightly tosses a ball of mass m upward. What happens to the ball? In this question, the key word is lightly, which implies that the initial kinetic energy of the ball is small. According to our common sense, we can tell that C is the correct answer. But let's think like a physicist. We can see some words such as orbit, Earth, surface of the moon in those options. And here I would like to make an analogy. We know that the moon is orbiting around the Earth, and the Earth is orbiting around the Sun. So we can imagine what happens if we lightly tosses a ball on the Earth. Obviously, the result is going to be that the ball falls to the surface of the Earth. So C should be the correct answer. Now, I'm going to briefly explain why all the other options are wrong. For option A and B, if you toss a ball on the Earth, it is unlikely for it to be captured by the gravitational field of the Sun. So if you throw a ball on the Moon, it is not going to be captured by the gravitational field of the Earth. Option D, there is a gravitational force acting on the ball, so it won't hover. Option E, even though the gravitational field on the Earth is much smaller than that on the Earth, it is unlikely for a human to toss it fast enough so that it will orbit around the Moon. Question 8 is testing your knowledge of the electromagnetic spectrum. If you can't remember the spectrum, go to listen the song. In this question, you're required to put those AM waves in the correct order. They should follow the order such that the shortest wavelength should be on the top, while the longest wavelength should be at the bottom. The first thing I want to do is to convert wavelength into frequency, because in the song, the EM waves were presented in the order of increasing frequencies. We know that C equals to lambda f. So when we have the shortest wavelength, that means that we have the highest frequency. And when we have the longest wavelength, we have the lowest frequency. Now, it should be quite easy to spot the mistakes in each option. X-rays has higher frequency than ultraviolet, and radio has lower frequency than infrared. Therefore, option E should be the correct answer. Question 9. Find the current. We are given V, which is the voltage, and resistance in terms of R, so we just need to calculate the entire resistance of the circuit and then use the equation R equals to V over R total. Now, let's look at the circuit diagram. We have R and 2R in parallel, and then the combined resistor in series with another R. We can calculate R parallel first. So 1 over R parallel equals to 1 over R plus 1 over 2R. And by doing the calculation, we can see that R parallel equals to 2R over 3. The total resistance can be calculated by Rp plus R, which is 2R over 3 plus R. That equals to 5R over 3. Now, we can calculate the current by putting R total back into the equation. So R equals to V over 5R over 3. And we can put 3 on the top, so that's going to be 3V over 5R. And B is the correct answer. Question 10. We have a capacitor constructed by two conducting plates, and there's an insulator between them. Now the capacitor is measured to be C, and we're going to reduce the original area down to half of it. And we want to calculate the new capacitance. Given that a capacitor consists of two plates of equal area, we can use the formula C equals to epsilon, which is the permittivity between, and A, which is the area, and D, which is the separation between two plates. So we can tell that the capacitance is proportional to the area A. So, if the area is reduced to half of the original one, the capacitance should also be half of the original, and that makes A the correct answer. So question 11 is about pulleys. We know that the object being supported is m, and the gravitational acceleration is g. There are a few assumptions we make in this question. So the pulleys are massless, which means that we only need to consider the mass being supported. And it is also frictionless, which means there is no extra force. And the string is massless and inextensible. So based on these assumptions, we can tell that the tension on the string should be the same everywhere. Let's look at the question again. It says the mass is at the same height, which means that it is stationary. So if it is stationary, that means the resultant force should be 0. Now, I'm gonna to draw the force diagram of the mass being supported. So obviously it has its weight, mg, and there are two strings pulling it up, so the upward force should be 2t. We now know that 2t equals to mg, and the question says it is pulled by the force F at the end, so that means F equals to t. Therefore, 2F equals to mg, and F equals to mg over 2, which means B is the correct answer. So question 12. We have a particle with charge Q. We don't know whether that's positive or negative, but it doesn't really matter. And it has initial speed v. And is stopped by a potential difference v in a distance d and time t. So what's the initial momentum? Momentum is defined by P equals to m times v. We have the initial speed v, so we just need to find m. But that's gonna to rearrange lots of equations. So we can try to find the initial momentum in another way. Let's write down kinetic energy first. So Ek equals to half mv squared. If we try to express momentum in terms of kinetic energy, we will have P equals to 2Ek over v. So as long as we know the initial kinetic energy, we don't have to deal with the mass of the charge. Initial kinetic energy can be calculated by conservation of energy. The charge is decelerated by a potential v, so qv equals to Ek. Let's put it back into the equation of P. So P equals to 2q bigger v, which is the voltage, over smaller v, which is the speed. Unfortunately, that doesn't match any options above. But we can see q and bigger v are in all options. So we need to express smaller v in terms of d and t. We know that throughout the entire motion, the charge is being decelerated. So we can plot a graph of v against t. The vertical interception of the graph should be the initial speed, so that's gonna to be v. The horizontal interception should be the time when the charge is stopped. And the area under the graph should be the distance traveled, so that's gonna to be d. Therefore, d can be calculated by the area of a triangle, half vt. We can rearrange that to give v equals to 2d over t, and then put it back to the previous expression. So P equals to 2q bigger v over 2d over t, and we can put t on the top of the fraction, so that's going to be q bigger v t over d, which means option A is the correct answer. That's all for PATS 2017. If you have any question you would like me to talk about, please comment below so I will know that. And also, please subscribe the channel so you won't miss anything.